All right, hey there, welcome to the Unit 6 review video where we're just going to talk about the difference between proportional and additive relationships. It's really quite simple. You might remember that proportional relationships were just ones where you multiply or divide, and additive relationships were ones where you either add or subtract. So we're going to go through these first 8 examples. We'll talk about how to identify if they're proportional or additive, and we'll write the equations for the table of values. All right? Now, for the first one here, when we're looking at the fact that the 4 gets smaller and then the 3 gets smaller and so on, you have a couple of options. You could do 4 divided by 4. And of course, 4 divided by 4 would give me a 1, but it'd have to be a negative 4 for it to be a negative 1. So I could do 4 divided by negative 4, but then if I did 3 divided by negative 4, that's not going to be this answer right here. So we're not going to go with multiplication or division for this one. It must be subtraction. So now just ask yourself, what do you have to subtract from 4 to get down to negative 1? And it's the same that if you took 3 and subtracted this number, you'd get negative 2, and so on and so forth. So this one, since it's the subtraction, we know that this is an additive relationship. And the equation for this one would be that we're taking away 5 every time. So y is x minus 5. All right, for the next one. A lot of you are going to see this point right from the beginning and realize that the origin, the 0, 0, was a dead giveaway that we're dealing with a proportional graph. And that's because anytime we multiply something by 0, the answer is always 0. Now, when we look at the rest of the values to try to get the equation, we can see that we'd have to cut 2 in half. If I divide this by 2 and cut it in half right there, and same thing here by cutting that in half or dividing it by 2. So this one is proportional, and the equation for this one is we take half. Half of each of our x's gives us the y's. All right, now if we're looking for 0, 0, it's also okay to say, well, here I see 2, 0, so I'm probably not going to be expecting a proportional situation since it's not 0, 0. That being said, if we consider adding or subtracting, we are clearly subtracting because we're getting smaller. So just ask yourself, 2 minus what gives you 0, and that'd be minus 2. If you did 3 minus 2, you'd be at 1. If you did 4 minus 2, you'd be at 2. So this one here is an additive graph, and the equation would be y equals x minus 2. For the next one, it's also additive, except this one's going to be y equals x plus 2. So it doesn't matter if it's adding or subtracting, we can call them additive. All right, for number 5, when we look at 16 and the fact that it turns into a 4 and 12 turns into a 3, again, we're either dividing to get smaller or subtracting. And in this case, I think that the 4 and the 1 and the 8 and the 2 really make it obvious that here we're just dividing by 4. So anytime we're dividing by a number, remember we write that as a fraction. So 1/4 x is the same thing as dividing by 4. And this is a proportional table of values, proportional. So don't forget, anytime there's division in the table, you write the fraction, okay? All right, for number 6, the 12 turns into a 9, the 11 into an 8, and so on. So it looks like here we're taking away 3. So this is an additive graph, and the equation here would be y equals x minus 3. Now 7 and 8, they just turn the input-output tables horizontally, but that's okay because we can still see right here a 0, 0, which is a dead giveaway for proportional. And then 0, 3 here, this is a dead giveaway for additive. So 0, 0, we just got to figure out what we're multiplying in the other numbers. So what do we multiply 2 by to get 4? And what do we multiply 4 by to get 8? It just simply doubles, so the equation here is y equals 2x. And then for this one, since we know we're adding, it's like, all right, well, 0 plus what gives me 3? And is it the same here? 2 plus 3 is 5, 4 plus 3 is 7. So yep, this is additive, and the equation is y equals x plus 3. So it's fair game for the table of values to be vertical, like all of these. The table of values could be horizontal, like both of these. And friendly reminder, I'll highlight them now so that they stand out, that 0, 0 is a dead giveaway that you're looking at proportional. And if you see like 0 in a number, that's a dead giveaway that you're dealing with additive. Just be careful here. It's 0 to add 3 to turn into 3. But this one here, 2 minus 2 to get that 0. So this one was a subtraction graph, okay? All right, now you're going to try these 8 on your own, and so you can either pause the video now and then do these, or you can just keep taking notes with me. I'm going to keep going in the video now. We're still focusing on proportional and additive relationships in this part of the video. This is still Unit 6, but instead of just caring about identifying the relationship using a table of values, we should also be able to review how to graph the lines and what the characteristics of proportional versus additive graphs look like on the coordinate plane. So for the first example up here, we've got x plus 1. And I wanted to remind you guys that when it asks for the y-intercept, that's asking for b. All of our additive equations follow this format. And so the number that's in this spot is where the graph is going to cross the y-axis. For example, if I plug in 0, 0 plus 1 is 1. So I'm going to go ahead and plot that point because I know that the graph is going to cross there. Now from there, we have a couple of options. You can simply remember that additive graphs just go up 1 over 1, up 1 over 1. But something's telling me you're not going to really remember that. So let's just use this table of values here. If I plug in a -1, okay, -1 plus 1 is 0. If I plug in 1, 1 plus 1 is 2. And if I plug in this 2, 2 plus 1 is 3. Okay? So if we plot those points, it's going to be these right here. You go back 1, and then not up or down. That's the first one. We'd go over 1, up 2, and then over 2, up 3. And when we connect, that is our additive graph, y equals x plus 1. Now it's okay if the constant is a negative number. That simply means that it's going to cross down below the origin at 0, -4. So we're going to go ahead and plot that point right here. And then again, the points should just go up 1 over 1, up 1 over 1, up 1 over 1. But in case you can't remember that, we can always plug them in down here using a table. So if I were to plug in a -2, -2, if I take away 4, it gets more negative. It's at -6. If I'm at -1 and I take away 4, now I'm at -5. And 1 minus 4 would be -3. So we can plot these points over 1 down 3, back 1 down 5, and back 2 down 6. And right there are the points. We can connect, and now we've got x minus 4. Now, while you guys are finishing that up, I just want to point out that the additive graphs here are parallel. If I move this example, number 1, if I move that over here, there's the x plus 1. So these lines are parallel, and if I put them now on the same coordinate plane, you can see what I mean by parallel. They'll never crisscross, they'll never intersect, and it's actually because they have the same slope, the same steepness. And I'm going to come back to how I can prove that in a second after I talk about these bottom 2 examples, okay? Now that being said, make sure you got your notes right here that additive graphs, by definition, their y-intercept is the constant in the equation. This red point is the y-intercept, and it is the constant, the number all by itself in the equation. And the slope that I just mentioned, it is 1 over 1, and that's the thing that I'm going to be able to prove to you guys. This little staircase is a 1 over 1. I'm going to come back and talk about that after we go through these next 2 examples, all right? So now that we've covered, these are the additive graphs. Okay, these were additive. Let's talk about proportional. And let's review, now that we have our coefficient here, that the coefficient is the slope. So here it's a 2, and here the slope is a 1/3. Now we're going to use our table of values here to plug it in. So if I plug in a -2 times 2, it's -4. -1 times 2 is -2. 0 times anything is 0. So again, dead giveaway, it's proportional. It'll go through the origin. So I'll go ahead and put that there. 2 times 1 is 2. And 2 times 2 is 4. So now let's just plot these points, okay? So we're going to go back 2, down 4. We've got back 1, down 2. There's the origin. Over 1, up 2, and over 2, up 4. When we connect, we can see we've got a proportional graph because it goes through the origin. Don't forget your arrows. And now let me review the slope being 2. That's the staircase thingy. You might remember when we talked about graphing these lines that we said that proportional graphs start at the origin, and then from the origin you can use the slope. So up 2 over 1, up 2 over 1, up 2 over 1. And you might remember that when it wasn't a fraction, we made it the fraction by putting it over 1. So that staircase that I just drew, that by definition kind of defines the steepness of the line. And that in this equation is a 2. So now when we look at this one, I don't even really need the table of values because again, it goes through the origin. And then from there, we can use this slope. We can go up 1 over 3, up 1 over 3. And I know we run out of room. So if we go down 1 and back 3, those points kind of fall in line. And again, you can still see the staircase, up 1 over 3, up 1 over 3. Now when we connect here, I'm just going to use that table of values below to check and prove my work to make sure we're all good to go. Taking a third of a number is the same thing as dividing it by 3. So just think about taking a third of 6, or 6 divided by 3 is 2. 3 divided by 3 is 1. 0 divided by 3 is 0. A negative 3 divided by 3 is a negative 1. And a negative 6 divided by a negative 3, or sorry, just divided by 3, sorry, negative 6 divided by 3 would be a negative 2. So when we look for these points, there's the back 6 down 2, that one checks out. Back 3 down 1, we're good. Of course, the origin we know should be good. Over 3, up 1, that point works. And over 6, up 2, that point works. So a question you might see on the SOL is if it gives you this line, it might say, hey, what is the slope? And the slope is a 1/3. And again, just think of that little individual staircase in the background. There it is. Here, the staircase was the up 2 over 1. And now I can come back like I was promising that if we look at these lines, see how it's up 1 over 1, up 1 over 1, up 1 over 1? And that is technically right here, that is the coefficient of x. I don't need to put it there. Anytime the coefficient is a 1, we don't have to write it. But that right there in green proves that for the additive graphs, we should always see an up 1 over 1, up 1 over 1 for the slope. Okay? So in this video, we reviewed the table of values and how to tell if it's proportional or additive with multiplying and dividing up here or adding and subtracting here. And I just reviewed the features of our additive graphs. Additive graphs here are parallel. They cross wherever you see the constant, and they have an up 1 over 1 slope. And then down here, when you see multiplying by a number like 2x, when you see a coefficient and you don't have a constant, now you know you're dealing with proportional graphs, and our proportional graphs will always pass through the origin, 0, 0. And that's because right here, technically I could put a plus 0 and it won't change anything, so it'll cross at the origin. The slope by definition is our coefficient. So anytime you see here a 2, the slope is 2 over 1. If it's already a fraction, you just keep it a fraction. And that concludes this video. Thank you for watching.